This is a video on Green's theorem and area. The question states, use Green's theorem to find the area of the ellipse x squared over 4 plus y squared over 9 is equal to 1. So let's start by sketching a picture. I have my ellipse, and I drew the region that I want to find the area of. I call that R. And I call the ellipse C, and I orient that counterclockwise. So the reason why Green's theorem can be applied is that Green's theorem relates the double integral over a region with the line integral over the curve C. And I can think of the area as a double integral over the region of 1 dA. And that turns out to be equal to the line integral over the curve C of negative 1/2 y dx plus 1/2 x dy. And the reason for that is if we take n sub x, we get a half. And if we take m sub y, we get negative 1/2. So n sub x minus m sub y is 1/2 minus a negative 1/2, which is 1. And that is a double integral over R of 1 dA. So now that we know we can use Green's theorem, let's parameterize the curve C. This is an ellipse, and the way we parameterize an ellipse is we let R of t equal, we say x is 2 times the cosine of t. That's like r cosine theta, but r in this case is the radius in the x direction, and that's 2. And then we can think of y being r times sine of t. And here, the r in the y direction is 3. So there's our r of t. Let's find r prime of t. The derivative of 2 cosine t is negative 2 sine t. And the derivative of 3 sine t is 3 cosine t. So now I can put all this together and say that the area of the region R is equal to the line integral over the curve C, and I can pull the 1/2 outside. Because we're looking at an ellipse, t is an angle, so it goes from 0 all the way around to 2 pi, so the integral goes from 0 to 2 pi. And then I have negative y, so that's negative 3 sine t, times dx. dx is negative 2 sine t. I pull the dt outside, and then we have plus x, and x is 2 cosine of t, times dy. dy is 3 cosine t, and there's the dt again outside. And this looks long, but actually it simplifies very nicely, because negative 3 sine t times negative 2 sine t is positive 6 sine squared t, and 2 cosine t times 3 cosine t is 6 cosine squared t. So I get 6 sine squared t plus 6 cosine squared t, and that's just equal to 6. So I have 1/2 times the integral from 0 to 2 pi of 6 dt. And that's just 1/2 times 2 pi times 6, which is equal to 6 pi. So I can conclude that the area of the ellipse is equal to 6 pi. And I'm done with the problem.